Physics and chemistry rule our world. Let's unlock their coolest secrets together. Welcome to Tell Me Why, where we uncover the craziest, most fascinating physics and chemistry wonders you never knew. From the science behind gravity, magnets, friction, and sound waves to the mysteries of heat, electricity, and motion, this video is packed with mind-blowing discoveries. Tell me why static electricity makes your hair stand up. Have you ever rubbed a balloon on your head and watched your hair stand on end? It's a fun and fascinating phenomenon that never fails to amaze. That, my friends, is the electrifying power of static electricity. But what exactly is happening here? Everything around us, even our hair, is made up of tiny particles called atoms. These atoms consist of protons, neutrons, and electrons. When you rub certain materials together, like that balloon in your hair, electrons can jump from one to the other. This transfer of electrons is what creates static electricity. The material that gains electrons becomes negatively charged, while the one that loses electrons becomes positively charged. This imbalance of charges is the key to static electricity. Opposites attract. So when your hair becomes negatively charged, all those strands try to get as far away from each other as possible, making it stand straight up. It's like a tiny electric force field around each hair strand. Static electricity is more than just a hair-raising experience. It's what makes lightning crackle across the sky. The same principles apply on a much larger scale during a thunderstorm. And it's not just in the sky. Static electricity gives you a little zap when you touch a doorknob on a dry day. This happens because your body builds up static charge, which is then released when you touch a conductive object. So next time you experience static electricity, remember, it's a small but powerful reminder of the invisible forces at play in our everyday lives. Tell me why magnets attract and repel. Magnets! They're fascinating objects that have intrigued humans for centuries. They're like little pieces of magic, attracting some things and pushing others away. But how do they work? There's no hocus pocus here, just the fascinating forces of magnetism at work. Magnetism is a force that can attract or repel objects. Every magnet has two poles, a north pole and a south pole. These poles are the key to understanding how magnets interact. Think of them like the opposite ends of a battery. Just as a battery has a positive and a negative end, magnets have their own distinct poles. Opposite poles attract, while like poles repel. This means that the north pole of one magnet will attract the south pole of another. When you bring the north pole of one magnet close to the south pole of another, bam! They pull together with an invisible force. It's almost like magic. But try to bring two north poles or two south poles together, and you'll feel an invisible force pushing them apart. This repulsion is just as strong as the attraction. This invisible force is called the electromagnetic force, and it's one of the fundamental forces of the universe. It's what governs the behavior of magnets. It's what makes magnets stick to your refrigerator and helps compass needles point north. Without this force, our world would be very different. Tell me why gases expand when heated. Ever wonder what makes a hot air balloon float? The answer lies in the fascinating behavior of gases when they heat up. Gases are made up of tiny molecules that are constantly zipping around, bumping into each other in the walls of their container. When you heat up a gas, you give those molecules more energy and they start moving even faster. This increased pressure pushes outward on the walls of the container, causing the gas to expand. That's why a hot air balloon inflates and rises as the air inside is heated. Tell me why water boils at a lower temperature on a mountain? Ever notice that it takes longer to cook pasta when you're high up in the mountains? That's because water actually boils at a lower temperature at higher altitudes. Air pressure is the weight of the atmosphere pushing down on us, and it's lower at higher altitudes because there's less air above us. Since air pressure is lower at higher altitudes, it takes less energy for the water molecules to escape as steam. So while water boils at 100 degrees Celsius, 212 degrees Fahrenheit, at sea level, it might boil at only 90 degrees Celsius, 194 degrees Fahrenheit, on top of a mountain. Tell me why objects fall at the same speed, regardless of weight. We've all heard the story of Galileo dropping objects from the Leaning Tower of Pisa to prove that objects fall at the same rate, regardless of their weight. This was a groundbreaking experiment that challenged the long-held beliefs of the time. Gravity does indeed accelerate all objects at the same rate. which is about 9.8 meters per second squared here on Earth. However, there's a catch. This uniform acceleration only holds true in a vacuum. Air resistance, the force that opposes the motion of objects through the air, can throw a wrench into things. It acts differently on various objects depending on their shape, size, and speed. Air resistance depends on the shape and surface area of an object. For instance, a flat piece of paper will experience more air resistance than a crumpled one. So, while a feather and a bowling ball dropped in a vacuum would fall at the same rate, without any air resistance to slow them down, in the real world, the feather's larger surface area creates more air resistance, causing it to float down gently. Meanwhile, the bowling ball, with its smaller surface area relative to its weight, encounters much less air resistance and plummets to the ground with force. This fascinating interplay between gravity and air resistance explains why objects fall differently in our everyday environment. Tell me why balloons pop when overinflated. We've all been there. You blow and blow into a balloon, trying to make it as big as possible, and then pop! The sound of escaping air and a deflated piece of rubber are all that remain. Balloons are made of elastic materials like rubber, which can stretch to accommodate a certain amount of air. As you blow air into a balloon, the air molecules inside push against the walls of the balloon, creating pressure. The more air you blow in, the greater the pressure inside the balloon becomes. At some point, the pressure becomes too great for the rubber to handle, and it stretches beyond its limit. That's when the balloon pops. Tell me why sound travels faster in water than in air. Ever notice how you can hear sounds more clearly underwater? That's because sound travels faster in water than it does in air. Sound waves are vibrations that travel through a medium, such as air or water. The speed at which these waves travel depends on the density of the medium. Water is much denser than air, meaning its molecules are packed closer together. This closer packing allows sound waves to transfer energy more efficiently from one molecule to the next, resulting in faster sound travel. Tell me why black surfaces absorb more heat. Ever notice how black cars get hotter than white cars on a sunny day? It all comes down to the way different colors absorb and reflect light. Light is made up of all the colors of the rainbow. When light hits an object, some of the colors are absorbed, while others are reflected. Black objects absorb all colors of light, converting them into heat energy. That's why black surfaces get hotter than lighter colored surfaces when exposed to the same amount of sunlight. So, the next time you're choosing an outfit for a hot day, remember the power of light absorption. Tell me why friction slows things down. Friction. It's the force that opposes motion whenever two surfaces rub against each other. It's what makes it hard to push a heavy box across the floor, and it's what allows us to start fires by rubbing two sticks together. When two surfaces slide against each other, their microscopic bumps and grooves interlock, creating resistance. This resistance converts some of the kinetic energy of the moving object into heat energy. That's why your hands get warm when you rub them together. Friction plays a crucial role in our everyday lives. It allows us to walk without slipping, it helps cars brake, and it's what makes it possible to write with a pen on paper. Tell me why metal expands when heated. Ever wonder why sidewalks have gaps between the concrete slabs? It's all about accommodating for the expansion and contraction of materials like metal in response to temperature changes. When you heat up a material, its atoms vibrate faster and move slightly further apart, causing the material to expand. Conversely, when you cool down a material, its atoms slow down and move closer together, causing the material to contract. That's why metal bridges are designed with expansion joints, which are gaps that allow the bridge to expand and contract without putting stress on the structure. Thanks for watching. If you enjoyed learning about these incredible science wonders, don't forget to like, subscribe, and hit the bell icon for more awesome trivia and mind-bending science videos. Stay curious and never stop exploring the wonders of the universe. See you next time.